When I say a leading coefficient of 1, again, we've got a trinomial where the leader, which our leader being the degree 2, has a coefficient of 1. And if we wanted to factor this, again, think of it as a trinomial. Again, that means 3 terms. And we want to factor it into a pair of binomials, not necessarily the same 2 binomials, but 2 things that when we multiplied the 2 binomials together, that these 2 would be equivalent to each other, and that one is the product and these 2 down here are the factors. Now the way we can do this is we can sometimes just make a little shopping list, and what we need is we need 2 numbers that when you multiply them will give you this third value here, which is the plus 16. We also need whatever these 2 numbers are, that when you add them, they have to be the exact same 2 numbers up here, which are question mark, that they add up to give you a plus 10, which is the middle term. Now, we do have ways to label these. This is like 1 would be your A, plus 10 would be your B, and plus 16 would be your C. But let's think about it. Now, what are these numbers? What 2 numbers when you multiply give you 16, that when you also add them give you plus 10? One thing you can do for this is you can think about, like, what are all the numbers that multiply to give you 16? 1 and 16, yes, is true, but 2 and 8, and then we've also got, there's nothing 3 times nothing, but then we've also got 4 times 4. And you can see it, right? If you take a moment, notice that it's 2 and 8 are the 2 numbers that will work. And you are trying to be real specific about plus and minus. In this case, they both need to be plus 2 and plus 8. Those multiply to give you positive 16, and plus 2 with a plus 8 gives you positive 10. And when you have found these numbers, they will be the constant that belongs in each of these 2 factors. And you could check yourself, does x plus 2 times x plus 8 really give you, and for that you could use something like the box method or FOIL method, where if you were to multiply these 2 things up, x plus 2 and x plus 8, this would give you x squared, this would give you 2x, this would give you 8x, and then this would give you 16. And if you combine those terms, you're going to get x squared, 10x, and 16. That's just a quick way to check that, yeah, this right here is the correct factorization for that trinomial. Okay. Let's try another one. Again, what I'm working with here is whenever you've got a trinomial where the lead coefficient is a 1, we're trying to see what 2 factors that this trinomial could be rewritten as. Again, just make yourself a little shopping list. You're asking yourself what 2 numbers or what 2 factors when you multiply will give you a negative 30. Again, this is our A, plus 7 is our B, and C is our negative 30. But you also need these 2 numbers, whatever they are, that when you add them together must give you plus 7. So take some time to think about this, but what can also help move this along is think of all the numbers that multiply to give you negative 30. Well, for now, just think about what numbers give you 30 just in general. 1 and 30, 2 times 15, 3 times 10, and nothing times 4, but then 5 times 6. And do you see 2 numbers that seem like they might be helpful, so that when you multiply them to get you 30, that they would also maybe combine to give you a 7, and that's going to be right here, the 3 and the 10. Because if you do 10 minus 3, that gives you 7. They are 7 units away from each other. So let's go ahead and put the 3 and let's put the 10 here. They seem to have the most potential. But how do we make this work so that one of them is negative, both of them are negative? What's it going to be? In this case, since we want it to be a negative 30, just one of them needs to be negative. But if we make the 3 a negative, and sometimes trial and error works, that will give us negative 30. but will it work down here if 3 is the negative? And it actually will, right? Negative 3 plus a positive 10 would give you positive 7. Again, if we had actually done it the other way, negative 10, like this would be great, but it would not work down here. That would give you negative 7. Again, sometimes you just have to do a little bit of trial and error, but negative 3 would work. So it would be x times the x, and it would be a minus 3 plus a positive 10. Again, maybe I'll put my signs up here. This should be a plus 10, just to be real specific. But if you were to FOIL those or do the box method, just like we did earlier, that's the box method. You should see that this does multiply out to give you a x squared, a 7x in the middle, and a minus 30. All right, so that's factoring trinomials where the lead coefficient is a 1. What then could we do afterwards? What happens if the lead coefficient is not a 1? Maybe it's a 2, a 3. In this example, it's a 12. But I'm going to end this recording, and I'll try some of that.